Greetings, and welcome to a lecture on the 8 Queens problem. Now, besides being a fun little chess logic puzzle, this is a very traditional problem to try and solve using recursion. But before we get to the recursion and the computer sciencey part of it, let's go over exactly what the 8 Queens problem is. So a queen in chess, if you are not familiar with the rules, is a piece that can move in any direction for any amount of spaces and take or remove any piece that's in its way. So if I were to represent this with lines, say from this queen right here, it would be able to move anywhere along this line, anywhere on this line, anywhere on this line, and anywhere on this line. These represent the paths that this queen can move, and if there is a piece in its way, say like right there, then this queen would be able to take this piece right here. So the 8 Queens problem is, can you put 8 queens on a chessboard in such a way that they cannot take each other? And so in this particular case, we have a dead board, because I've got this one last queen here to place, but there's literally no place that I can put it. Each row can only have one queen by definition. So this row, this one, 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 all of these rows here already have a queen on them. So this is the only row that I can place a queen on. Likewise, every column has to be unique. And sure enough, done, 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 all of these columns have a queen on it. So this is the only column. This is the only row. This is literally the only spot that I can place a queen, but I also can't put it here because now these 2 queens can see each other. This is an invalid position. This is a dead board. I cannot solve the board with the queens positioned like this. And you can see how it would potentially take quite a bit of time if you were not very good at visualizing chess, moving these pieces around to try to place them in such a way that you have all 8 queens on the board, but none of them can take each other. So that is the 8 Queens problem. So let's take a look at how would we represent this in terms of a programming problem, specifically recursion. I'm going to get these off the board, and we're going to look at just a subsection of the board to make this a little bit easier. We're just going to look at a 4x4 area of the board. So this is going to be our playfield. This is going to be the 4 Queens problem. And then I'm going to use these little white pieces over here to represent our function calls. So one way of thinking of this problem, I have rows and I have columns. And I know that I can only put 1 queen per column. And so I can frame my function at that term. You could also do this rows. Rows would also work perfectly fine. I just like thinking of it in terms of columns. 6 of one, half dozen of another. So I'm going to have a function called place queen. And I'm going to pass in a column number. And to make this clear, let's just go ahead and put in some column numbers here. So we're going to go 0, 1, 2, 3. Not the most expert of placement of things, but it works. So we've got column 0, 1, 2, 3. Because in computer science, with computers, we always want to start counting with 0. Because if we represent this with an array, which we probably will want to do so, this is 0. Standard array stuff. So I'm going to say place queen 0. So column number 0. And so now we have our first function. So the little piece up here represents we have 1 function open. And I'm going to have a for loop that just simply checks for each row on the board. And once that for loop ends, that's going to be the end of the function. That's how I know I'm going to end my recursion. Remember, we always have to think about when we're doing recursion, what's going to stop the recursion calls? Well, in this case, I'm going to do a for loop. Once the for loop is done, then the recursion calls stop and things can start unwinding. And so for every loop, in the for loop, I'm going to ask a few questions. Is valid placement? Well, this is my first piece, so obviously this is a valid placement. Yes. So is valid? Yes. Is column number equal to max? In this case, since it's a board size of 4, my max is 3. 0 is not 3, so no. So now I'm going to say place queen column plus 1. 0 plus 1 is 1, so we now have another function open. And now we're in this function call. Is this valid? No. Is valid? No. Is valid? Yes. Is column equal to max? No. Place queen column plus 1. 1 plus 1 is 2. We now have a new function open. And here we go again. Is valid? No. Is valid? No. Is valid? No. Is valid? No. Function ends. So we go back here to this function now. Move to the next iteration of the for loop. Is valid? Yes. Is max? No. Place queen column plus 1. So place the queen. We have another function. Is valid? No. Is valid? Yes. Is max? No. Place queen column plus 1. 2 plus 1 is 3. So now we've got another function open. And now we're here. Is valid? No. 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 Function ends. We go back to this function. Is valid? No. No. Function ends. We're now back to this function. That was its last for loop iteration. So that function ends. So now we have unwound all the way back to our original function. Next iteration. Is valid? Yes. Is max? No. Place queen column plus 1. So again, another function call. Here we go. Is valid? No. 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 Yes. Is max? No. Place queen column plus 1. We have another function. 1 plus 1 is 2, so we're up here. Is valid? Yes. Is max? No. Place queen column plus 1. We're now in another function. Is valid? No. No. Yes. Is max? Yes. Report valid solution. Again, remember, we're thinking at this point, it's worth stating this, we are thinking in terms of pseudocode. We aren't worried about implementation at this stage, right? We're just more worried about thinking about this in terms of a computer program, explicitly stating out steps and sequences of events. What am I doing? So it is perfectly valid at this stage of algorithm development to just simply say, report valid solution. How am I going to do that? I have no idea. I don't care right now. I just know that, yes, okay, this is in fact a valid solution. And the algorithm that I'm stepping through is going to find that. So I am going to report valid solution. Continue on with the for loop. Is valid? No. Function ends. Close it out. Return back to this function. Valid? No. 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 Function ends. Close out. We've unwound back to this one. There's nothing else to do for that particular function, so closes out. And now we've, again, unwound all the way back to the original function. Now I'm not going to finish going through every solution here, because at this point it mirrors. Now, if you want to be really clever about it, you could, once you've done half the board, figure out what the mirror solutions are. But I would advise you to not try and get that fancy when you go to do this assignment. But in any case, back on the original function, I would go down here. I would repeat the whole process again until I've unwound back here, place it here, go through the whole process again, until I have finally unwound back to here again. That function ends, and the original function has now completed, and due to having reported valid solutions, I can now do whatever it is I want to do with these solutions, which in the case of the assignment is going to be reporting how many there are, and then an ASCII representation of the chessboards. So that is the 8 queens problem, and a sort of pseudocode step through of an algorithm that would be able to solve the 8 queens problem. Now that we have our algorithm, we have to start thinking about implementation. More specifically, how am I going to represent the board, and how am I going to represent queens? As far as the board representation goes, there's a very clear data structure that will let us do this very easily, and that is an array. And we can do this in both a single-dimensional or multi-dimensional array. They both have pluses and minuses to doing it that particular way. I would advise doing a multi-dimensional array, which is something we haven't talked about yet, and that's going to be the next video. So again, this is split up into 2 videos. We have this one, which is the discussion of the 8 queens problem, and there'll be a follow-up video that is going to be a discussion of multi-dimensional arrays and how to navigate through them. So that way you can watch whichever video that you need to study for whether you're trying to remember or get help with the 8 queens problem, or if you need to look at multi-dimensional arrays. So with that, I am going to wrap this one up, and I'll catch you on the next video.